was in previous class we have discussed section ratio formula, and so far we have discussed the distance formula to calculate the distance between 2 points as root over x2 minus x1 whole square plus y2 minus y1 whole square. This much units we have discussed. Then in section ratio, to find the coordinates of a point which divides a line segment AB in two parts having ratio m is to n. Say this point is C, then to get its coordinate we have invented the formula that x is equal to mx2 plus mx1 by m plus n, then y equals to my2 plus my1 by m plus n. Further, if C is the midpoint, we have invented that x is equal to x2 plus x1 by 2. Similarly, y is equal to y2 plus y1 by 2. Again, for centroid of a triangle, we have also discussed centroid of a triangle formed by the points x1 by 1, x2 by 2, x3 by 3 will be given by x1 plus x2 plus x3 by 3, y1 plus y2 plus y3 by 3. Similarly, this one is the case of internal division, and we have also discussed the case of external division where the ratio m is to n. Here, if the direction of n be taken as positive, the direction of n will be negative. And we have deducted that the formula is mx2 minus mx1 by m minus n. Similarly, my2 minus n1 my1 by m minus n. So this thing we have discussed in previous classes. Now, we should discuss area formula. That formula is also important an important formula for this branch. So, to get the area of a triangle which is formed by 3 points, see, we have two axes. This one is the origin, this one is x-axis, this one is y-axis. Now suppose we have 3 points, 1, 2, and then this one 3. This one is A, this one is B, this one is C. Suppose A has got coordinates x1, y1, B, x2, y2, C, x3, y. Now for these 3 points, if we join them by means of a line segment, we will get a triangle. This triangle ABC. The triangle may be acute, obtuse, right angle, maybe scalene, isosceles, or equilateral triangle. Any triangle we may have. To get the area of this triangle, was you have studied in class 9 and 10 that area of a triangle is nothing but half base into height. And for ICSE and CBSE students, they also know that area of triangle using Hidalgo's formula, that root over S into S minus A into S minus B into S minus C, where S is the semi-perimeter, that is sum of lengths of 3 sides of triangle divided by 2. So this formula you know. Now here we will deduce a new formula for finding the area of triangle in this coordinate geometry. Now how to get that formula? Suppose we have brought a perpendicular AD from A on x-axis. First coordinates of A are x1 by 2. So for point P, its coordinate will be x1, 0. Now, if we drop a perpendicular from P, that is PE, on x-axis, the coordinates of E will be x2, 0. And if we drop a perpendicular CN from C on x-axis, the coordinates will be x3, 0. You can easily understand this thing. We have discussed in previous classes also. Now, if you want to find the area of this triangle, what you have to do, You see, this A, B, F, C, this 4, it is a trapezium. This quadrilateral is a trapezium. Why? Because this angle is 90 degree, this angle is also 90 degree. So, on a single line, if two lines are perpendicular, they must be parallel. So, for a quadrilateral, if two sides are parallel, it must be a trapezium. Now, for this quadrilateral, from this quadrilateral, you just try to find out the area of this trapezium. Then subtract the area of this trapezium. You see here, this one is also a trapezium. This A, B, E, P. This one is also a trapezium. Similarly, this one, that is C, F, E, B. This one is also a trapezium. Now, if we find the area of these two trapezium, and if we subtract this area from the whole trapezium, we will get the area of this trapezium. Now, let us see how we are going to calculate this area. First, you see this length OD is x2 and this length OD is x1. So, what about this length? This length is x2 minus x1. You can check it. This length is x2 minus x1. If you calculate this length, this distance, then this distance will be x3 minus x2. x3 minus x2. Just like EF. And again, if you calculate this length BF, this length will be x3 minus x1. This length EF. You can easily observe that this whole length is x3, this length is x1. So if we subtract it, we get x3 minus x1. Now, this length, this ordinate is the ordinate of point A. This length is y1. This length, the ordinate of point B is y2. And this length being the ordinate of point C, it should be y3. Now, y1, y2, y3. Now, you know, for area of trapezium, how to calculate this area? You know, it's half into sum of parallel sides, multiply cross distance between them, into distance between them. Now, boys, we will try to apply this formula for these three trapezium. What happens? You observe it here. Therefore, area of triangle ABC is equal to half. Boys, you see, the area of the bigger trapezium, sum of parallel sides, that is y1 plus y3. This length is y1, this length is y3. So half into y1 plus y3 into the distance between them. What is the distance between these two parallel lines? You can see that the distance is x3 minus x1. So this length x3 minus x1 minus from area of this bigger trapezium, we have to subtract the area of this one as well as this one. So first of all, try to subtract the area of this trapezium, that is half. Then sum of parallel sides. You see here, this one is y1 and this one is y2. So sum of parallel sides is y1 plus y2. Then distance between these two, that is distance is x2 minus x1. x2 minus x1 minus half. Again, subtract the area of this trapezium. y2 plus y3. y2 plus y3. Then distance between them, these two, that is x3 minus x2. So this whole is your area of triangle ABC. Now we will try to represent this area in a systematic manner. How? You see, just show me these results. Now, you can write this whole calculation in some simplified manner so that you can apply it very easily. How? You see, area of triangle ABC is equal to half. You can take half now, 2 Now what happens in the bracket? In the bracket, the first part is y1 plus y3 into x3 minus x1. Then minus y2 plus y1 plus y2 into x2 minus x1. Then minus y2 plus y3, y2 plus y3 into x3 minus x2. This thing you will get in the bracket. Now, try to open these brackets. What happens? You see here, half in the bracket. If you open all these brackets, how to open it? You just see here. Just we will multiply x3 with these two. This y1 plus y3 to be multiplied with x3. Again, what happens? x3 into y1 plus y3. No problem, y1 plus y3. Then minus x1 into y1 plus y3. Check out the multiplication. Again, here, minus x2 into y1 plus y2. Again, plus, it becomes plus x1 into y1 plus y2. Again, minus x3 into y2 plus y3. Then minus, so plus, it becomes minus into minus, it becomes plus x2 into y2 plus y3. So this result you will get after multiplication. Now try to write in order. Order means first write the term containing x1, x1 is here, x1 is here. So how to write it? You see here half. You can write x1 first. Then in bracket you see here this one is positive. So first we write this y1 plus y2 in bracket. And then here we have minus. So minus y1 minus y3. This result you will get. Then plus x2. Here is plus x2. We should write in bracket y2 plus y3 minus, again this one is minus, so minus y1 minus y2. Then plus x3. What happens? This one is positive, so you should write y1 plus y3 in bracket minus y2 minus y3. Now what happens? You see here, the term cancels out and you will get the area of triangle in a simplified form as half in the bracket x1. Here you will get y2 minus y3. This y1 cancels out. So you will get y2 minus y3 plus x2. You will get what? y2 cancels out. You see here y3 minus y1. And then the third one, that is x3. You will get y1 minus y2. So this much will be your area of triangle. Square unit should be added for writing any area. This much is square units because area always exists in terms of square units. So whenever we are going to calculate the area of triangle, we should apply this formula. There is a way to remember this formula. You see boys, just prepare the circle and cut this circle at 3 places. y1, y2, y3. Now you see, if you are writing x1, then leave this y1. After writing x1, leave this y1. You have to write y2 minus y3. Then if you are writing x2, leave this y2 and you have to write y3 minus y1. And then if you are writing x3, leave this y3, you have to write y1 minus y2. x3, this last one should be y3 cancels out. You see here, in front will be y2 minus y2. So that mistake which we have done here, it should be y2. Now, so in this way you can remember your area formula. Now there is one more technique with the help of which we can remember this formula. You see here, the same formula can be represented in one more way. How? You see, what we have to calculate the area of triangle formed by the 3 points x1, y1, then x2 y2, then x3 y2. Write these 3 points separately one by one in your graph form. And then once more write the first value, that is x1, y1. Now if you are trying to write the formula, that is area of triangle ABC, you can write it easily from this result. How? You see, area will be half, then in bracket. You must multiply these terms in first bracket. Left top to right bottom, left top, right bottom, left top, right bottom. This much. 3 terms to be multiplied and written in one bracket with plus sign. What happens? x1, y2, then plus x2, y3, then plus x3, y1. So this one is your first bracket. Now minus, you should write the remaining product from right bottom to left top. Right products in this bracket. That is x1, y3 plus x3, y2 plus x2, y1. Because we are square units. Whereas you will find that this formula and this formula both are same. If you open this bracket and arrange the term, positive term in one bracket and negative terms in another bracket, you will get this formula. So this is one more easier way to apply area formula directly. Now, we have to apply this formula, this technique in few problems, and we have to calculate the area of the figure. But there are some more concepts here that the same problem or this problem can be applicable to find the area of a quadrilateral also. For example, suppose you want to calculate the area of a quadrilateral, and you know boys, a quadrilateral is formed by 4 points. So the first one is x1, y1, the next 2 y2, x3, y3. The fourth one should be x4, y4. Then once more write the first value, that is x1, y1. Now do as you have done for finding the area of triangle. Means you have to take the first products in one bracket and the second products in another bracket with half. That is area of quadrilateral. Area of quadrilateral is equal to half, and then in bracket you have to write these products in one bracket and then minus the next product in another bracket, these products in another bracket, so that you will get the area of this quadrilateral. Similarly, you are able to find the area of a pentagon also. If the pentagon is formed by 5 points like this, and if it is asked to calculate the area of this pentagon, you have 5 coordinates. So write the 5 coordinates one by one. Then once more write the first one. Area will be half into, then the product minus, then again the product. So in this way you can calculate the area of a quadrilateral, triangle, pentagon, whatever the shape may be here in coordinate geometry. One more thing I want to discuss here was area of a figure will never be negative. Area of a figure, it will never be negative. Never be negative, it means that if you are saying that you have purchased a flat having area 1000 square feet, yes, it is true. But what about that flat whose measure is minus 1000 square feet? It has no meaning. So this area, if you calculate it, it remains always positive. And for that, we always write the formula for area in modulus sign, not in bracket. You just put mod and then keep mod here. This mod makes our result always positive. So what this modulus stands for, you see here, if it is mod 5, the value will be 5. And if it is mod minus 5, the value will be 5. Again 5. If a quantity under modulus is negative, it should be taken as positive. positive, it remains as positive. Clear? So, we always put modulus sign for finding the area of a triangle. Though, if you are not putting this modulus sign, and if you are calculating this area using bracket, and at last if you are getting minus 40 square units, then in the next step you should get it plus 40 square units, so that area, and right here area will never be negative. It should be 40 square units. Clear? Now, let us take a problem on it and we will try to calculate the area. Suppose if it is asked to find the area of a triangle, find the area of a triangle formed by 7, 9, 3, minus 7, minus 3, what? These are the 3 points. These 3 points forms a triangle, and you want to find the area of this triangle. So we can write here directly. Therefore, area is equal to half. We can put a modulus. Now you just put the points here, 7, 9, then 3 minus 7, then minus 3, 3. Once more you need to write the first one, that is 7, 9. Now try to put the first bracket. What happens? 7 into minus 7, it becomes minus 49. Again, 3 into 3, it is 9. So plus 9. Again, minus 3 into 9, it is minus 27. So this one will be your first bracket, minus. You can write 7 into 3, that is 21. This one. Then minus 3 into minus 7, that is plus 21. And then 3 into 9, that is plus 27. So now put mod here. Now what happens? You can see here half mod. Here you are getting 40 and then minus 27. It should be 13. I think it should be 13. Go and check the calculations. For minus 49 plus 9, it becomes minus 40. No, sorry, it becomes minus 67. Sorry, minus 67. And then here minus. What happens? 21, 42, 42, then 69. It becomes 69. Modulus. You must put here. After that, half, then mod, 7 and 9, 6, 6, 12, 13, 136 minus 136. Why? Now see here. Here, this area, if you do not put modulus sign, it appears as negative. So, to omit this negative sign, we have taken this modulus. Now, what happens? This is equal to 136 by 2. That is 2 6 are 12 and 2 8 are, I think 68 will be your square units, will be the area of triangle. So this much is your area of this triangle. One more concept is there was, suppose we have a triangle. Suppose we have a triangle. Now this triangle has got some area. ABC is a triangle. And this triangle has got some area. Suppose point B and C are fixed. And now this point A is moving. After during its motion, suppose point A is here. Now if you join A with B and C, the position of A, if you join, you will get a triangle. And the area of this triangle is smaller than the area of the original triangle ABC. Further, suppose A again moves here. Then the area of this triangle is smaller than the previous one. Then suppose point A is here. The area is much smaller. Now what will happen if the point A reaches on this line BC? In that case, area becomes 0. Area becomes 0, it indicates that point B, A, C, the 3 points lie on a straight line. And this condition is called collinearity. Collinear. Points are collinear. So, for 3 points to be collinear, we should have the area of triangle formed by those 3 points should be 0. Well, now you area of triangle using this formula, area of quadrilateral using this formula, pentagon, or you can prove points are collinear using this formula. I think all of you can easily understand it. And now try to solve the problems based on these three topics: distance formula, section ratio formula, and area of triangle. In the next class, we will discuss the next topic. Thank you, class.